I draw it here, let's take a quick time to go into explain, right? Right, we're gonna explain your household circuit. Right, take your picture, and I want you to watch your picture. And then we're going to talk about some of the things that, right? Actually, you know what, there's not one, yeah. Hold on, before you take it good. I will know. Where am I? Hold on, I just look at our next one, right? That one next. And that's it. Alright, so go. Let's just go back and use the one that we had from before, right? Alright. So if you look here at this household circuit has a few main components, right? Right? There's a nicer one, but anyway, the household circuit, look at the wiring, right? So if you look at the wiring, first thing first, we have the pole, and that's TNT pole. Then we have a big cable, as the homework is going to look at it, right? You have a big cable going to your electrical wire, then you have a big cable going to your house. And wait, notice those? Yeah. So you have a big node, that might be the ground. Right? So you have these big cables taking electricity from the poles to your meter, and then from your meter to the house. Then from the house, they are split up into three main circuit, three main wires, right? Like we're looking here, I can see it, on the public can see it, right? If you look in the if you look in your wiring at home, there are three main wires. There's a brown wire, there's a blue wire, and there's a green wire, or green and yellow wire, right? Those are the three wires that kind of make up the current carrying wires in your household, right? If you look closely and get to investigate, you will see that the blue wire is the live wire, right? The blue carries all electricity and is the neutral. So remember, in a circuit must start and finish, right? So it must have a beginning and completed and an ending, sorry. The blue part is what will carry electricity, and the brown is what will complete the circuit. So we call the blue live and we call the brown neutral. Okay? Anybody ever stick your finger in a socket and you realize you only get shocked from one of them? Right. You only get shocked from the one with the blue. The one going shock you and the green. The purpose of the green is called flux. So in case of a surge of current, it will pull it away. All right. So you have three wirings in your home: brown, blue, and the green and yellow. Green and yellow is that's connected to a pole somewhere outside the house. So in case of a surge, it'll pull all the electrons out to the ground and neutralize them. Brown and the blue are those are the ones that help complete the circuit. All right. So let's take a look at our diagram, right? So our electricity came in from the poles is in the electric meter. TNT will measure how much you're using, right? And then your main wire now, your main wires that the brown and the blue are connected. If you look closely, you will see. Let's follow the blue. Follow the blue. The blue come in here, come in here. You have the little switches here. Those little switches most of the time might be breakers, right? Follow the blue, right? Follow the blue here, and then you'll recognize that all these blue, they will start to go into the right. Actually, this one labeled opposite, right? Take these labels in now. I want to use this one. Take that down. In an electrical household, brown, they use brown as light, blue as neutral, and green and yellow as blue. Make a note of that, because I'll have to use that in this circuit. So instead of following the blue, let's follow the brown. So in an electrical circuit, change the coloring. Copy that down. If you have a brown and a blue and a green and yellow pen, you can color code them. So we're using brown as light, we're using blue as neutral, green and yellow as lit. Okay, nice. Let's go back to our circuit, right? So I'll follow the wrong one, sorry. So let's follow the brown. So the brown now carrying the electricity And you will notice that the ground is connected to the breakers. Right? You'll ever saw your panel box at home? Right? Look for your panel box at home and open it, and you'll see these little black things with little switches on them. Those are breakers. Those are electromagnetic by nature. So if current is too large or too small, it'll trip it off. And then no current will flow in that part of the circuit. That's okay? Those are breakers. Long ago, they had fuses, but the problem with a fuse is what? If a fuse blows, they're going to take it out and put in a new one. Breaker now, if the breaker trips, right, you'll get a click. All you have to do is put back on. All right? So I wanted to notice, probably make somebody go outside and what you want outside, right? I want you to notice that each of these breakers has its own electrical supply. You'll see that? Each one of them has its own supply. Everybody seeing that, right? So what will happen is, let's say in our room here, we have 1, 2, 3, 4 light bulbs. We have some plugs and we have a AC, right? Do you want the same switch to control the AC and the bulbs? No, they want something else different. So the breaker now, one breaker will control the AC. So if something goes wrong with the AC, they'll trip and only the AC will come on. Right? And next will control the wire the bulbs and probably the plugs and sockets something. Right? So you will see different amounts. On one breaker, you might see 50 amps, right? That I might control a big AC like this, and then it might say 10 amps, right? That will control the bulbs and probably your switches. Your sockets. That's okay? Are you okay with that? So based on the amount of current you need, you will have a breaker. All right? What you'll notice about the breakers there, you'll think they're connected in series or parallel. Series, so if one breaker go up, all will go up? No, parallel, right? So parallel allows for individual control. Okay? So look at the circuitry, and then you might go see bulbs. Let's focus on one bulb. That's one bulb there. Right? You have current going into the bulb. And what's the purpose of the blue? Blue is to help complete the circuit. That's okay? So you have current going in and you have the blue coming out. To help complete the circuit. What you all think? Look at how these connections are made. Series of parallel. Most likely parallel. Okay? Most likely parallel. Good. Where do you put your switches on things? On your live or your neutral? Like all these switches in our room here. Where you put them? On the live. Okay? So you put your switches on your live. You okay with that? Alright. So those are some of the main things. Notice when you have, look at where the green is. Right, let's look at the water pump. The water pump, all the major devices. You have your water pump and your water heater. They have 3 connections. Current going in, you have your neutral to complete the circuit, and you have your earth. In case of a surge, it'll pull it out. Let's see if you can see where it's going, right? Let's follow it, follow it, follow it, follow it. Where are you going? That symbol there, you'll see that? That symbol there with 3 lines, I mean down in the ground. Right? So that earth going down in the ground. And you will notice you have 3 pins. So if you look at your plugs, you will see 3 pins. One is live, stick your finger in that one, neutral, and then you have your earth. Okay? So again, stick your finger in the live, that's in clear, right? Guaranteed to get shot. Neutral, nothing will happen, earth, nothing will happen. Okay? Homework, try and figure out which is which. Yeah. It wouldn't complete the circle. It wouldn't complete the circle. So you just needed to complete this circuit. So you would just have a flow of a series of electron and bias. And it's something you can take the electron combination. Okay. Right. So you have your 3 pins switches connected there. You have your blue, right? So this diagram is not impressed, but it shows you the main principles of it, right? What you will also notice is that you can't use those small wrong wires and wish I could show over here. After the hanging. But I mean wrong wires are thin. Those wrong and blue wires are thin. But if you look at the main electrical wire that coming from outside, so the house is much thicker, right? Because the current coming in is much larger. So if your house might be supplied with 200 amperes, that wire will have 200 amperes. If you look at a larger building like this, the wire that comes into a building like this will be a little bit bigger. If you look at some of those big hospital buildings, you will see a much larger wire, right? And they're expensive. All right. So those are the main principles of an electrical circuit, right? Let's just go over them one more time. Number one, the electrical coding, live, neutral, earth. What's the purpose of live? To actually carry the electricity, neutral, complete the circuit, earth to what? Right? Any excess electron, because sometimes TNTech might supply it with the same amount all the time. It might get a surge. You'll never see a high or low voltage, right? Low is bad, but high is even worse. Right? So at a high voltage, instead of the electrons going to your appliance and mashing it up, it will take it up. Right? You also have breakers connected to the lines. Right? Well, it used to be fuses a long time. But you also have breakers connected to the lines. And the purpose of the breakers is to help regulating current, right? If you need 20 amperes, you do not want 22 amperes flowing because there must be appliance. All right. So what you can do when you go home, take a look at the panel, look at the different sizes, and normally there's a directory. So it will tell you this 50 amperes is going to AC, your AC problem. Right? So there's a direction, right? We can do a little tour, we can walk around, we can watch you want to. Right? And it gives you an idea of what you're supposed to have a directory, right? It'll tell you 10 amperes just taking kid bulbs and so on, right? We have a dryer and washer, you will see a much larger breaker there. Right? Right? We have the wires, we have the switches, we completed the circuit and so on. Are you okay with that? All right. So let's just take some small notes on the household circuit. Right? Small notes on the household circuit, right? Right, in a household circuit, the wires are 3 types: live, neutral, earth. Live, neutral, and earth. Live carries live carries the electrons or the electricity in this circuit. Live carries the electricity in this circuit. Neutral helps to complete the circuit. And earth takes the excess electrons away. Sorry. Right, so that was the first thing, connected to the lights, so stuff connected to the lights. Connected to the lights. Yeah, next sentence, sorry. Next sentence, connected to the lights are breakers and fuses. Breakers and fuses. Connected to the lights are breakers and fuses. That are rated based on, that are rated based on the amount current needed in that part of the circuit. They are generally rated. They are generally rated slightly higher. Slightly higher. They are generally rated slightly higher than the current needed in the circuit. Right, so like if it's 15 amperes needed, it might be like an 18 or 20 amperes, slightly higher, right? Just a little bit higher. Next. Most components are connected in parallel. Most components are connected in parallel. Most components are connected in parallel to allow for independent control. To allow for independent control. Right, note that switches are always connected to lines. Note that switches are always connected to lines. And hoods. And hoods. Yeah. It's connected to the cooling ground. Right? So those are the things that we need to remember from our console circuit. Ideally, you should have one drawn, right? But I have an easier one than this. This is just the only one I'm finding right now, right? All right. Let's do a small question. Right? I don't know if you all remember this question that we were doing. Remember this one? Right. We didn't answer part 4. See if we can figure out part 4. What's an appropriate fuse that you should use? Right? What's an appropriate fuse that could be used in a microwave oven? Right? So you need to figure out the current that the microwave oven will need. And they give you a value there. Look back at all the formula that we used so far. Right here. So you get a current. Yeah, that's what. That's it. You figure it out. The camera formula. No power. Yeah, shot. Yeah. Because look at what I gave you. All I gave you was what? All I gave you was voltage and the power here. So you have power and you have voltage, and I want you to find what? Current, right? So I is equal to what? All right, go take a look back at that. I don't want to write everything down there. They just collect dust and look back at the formulas. I gave you formulas for power. I gave you formulas for energy. Right? So you need to find power there. right? And then choose the one that will work. Has to be a little bit more, right? Oh yeah, write down the values, write down the microwave, write down the voltage values, write down the power values, find the current, and then decide which you save. Online, any answer to that? Which one are you using? Huh? I think figure it out. What microwave and then someone. No. I can answer. We got one more time again. Right? So we do that. P is equal to what? P is equal to IV. Well, formula IV, right? I is equal to P over V. And P is what? P is 1100 and your voltage is 120. How much is that? 9 point? 9.17. So which fuse are you going to choose? 1 ampere? No, 10. So you're going to choose 10 amperes. That's all, right? Why I can't choose 5? Why I can't choose 1? Right? And if they have 20, why I can't choose 20? Too far, right? Nice. So that's the way you work it out. Write it down, please. So you have an example of this. How to choose a fuse, right? Right, so we kind of come to the end of the electricity. What we have to do still, we have to take a look at something called diode and rectification. Right? But we don't say know how to select a fuse, right? You'll see this one. All right, after the circuit. Find the total current. Let me see if I remember doing this. Which one there is the fuse? Which symbol there is the fuse? This, this, this. Oh shit. Get disconnected, sorry. I sorry that. Right, so the symbol for the fuse is this. Right, sometimes it might look like that, right? Look at the line in the middle. Right, this line is melt, that line melts, right? All right, do me a favor, find total resistance, total current, and then decide what size fuse to use. Okay, total current, total resistance, and decide fuse to use, right? Try that, please. Total resistance, total current, and decide fuse to use. That resistance, then total current, and then choose your fuse. That remember exactly that problem? 2, 3, 4. So if you know your value is bigger than that, do something wrong, right? And they are fast now to watch over. All you. Look at time. 2, 3, and 4. That's where it's choosing from, right? I'm going back to this circuit. Wrong. Something wrong. That'll be amazing. No. One. All right, let's check it out. Let's check it out here, right? So first thing first, I'm going to work out here. So that's 1 on R is equal to 1 on 4 plus 1 on 6. Right? That will give you 5 on 12. So you have to flip it over and you will get 12 on 5. Correct? So it means that I can take off this and take off this. And I will get 5. Sorry. I'll get 12 on 5, right? Which is how much? 2.4 ohms. So now 2.4, 2 and 3 are in series. So the total resistance is 2.4 plus 3 plus 2, 7.4 ohms. All right. So the total resistance is 7.4 ohms. Okay with that? That's the total resistance. Right? And now you want to find total current coming on top here. Current is equal to voltage on resistance. So that's 24 over 7.4, which is 3 point how much? 3.24 amperes. So what's the best rating to use? It should always be slightly larger, 4 amperes. Right? So we're choosing up 4 amperes. Good job, Narayan. You're okay with that? Right, Olya, when you're doing your working, right? Some of you all kind of get a little confused with the working, and you don't want the examiner to be confused. When you're working on the parallel, write that down. 4 and 6 in parallel, work it out. Right? And then that's in series 2 and 3, then work it out. Don't try and work all together. Because I saw somebody, when they work it out, they left it as 5 on 12 plus 2 plus 5 plus 3. Which is wrong. So work out the parallel first, then add it to the part in series. Right? That's the reason why I like to redraw the circuit. Right? So if I'm doing it, I would take off this and I would draw a new circuit. And that answer there was 2.4. Now I would put resistance in total and work out this and this. So it's easy for the examiner and it will reduce the mistakes that you make. All right? Don't try and jumble it all up. Okay? All right, so copy down first and take a look at it, right? All right. So that is the circuitry. I hope you understand how to identify series and parallel and how to work everything out, right? Okay with that? So we learn about fuses, household circuits, and things. Normally, this next part here, I'll give it for homework, but people don't do it, so I'm going to call it right. Next thing that we have to know is two types of supply, right? There's a primary, right? There's a primary and there is a secondary supply, right? Primary is like what we used to, like batteries on it. Secondary is like your car batteries, big batteries, like chargeable. Right? Normally I'll have to write a note on it, but no it's up. I will go my finger in the bench. There's our what kind of school we're going.
That's it.
Yeah. Alright, so before we go to the diodes, these are the things that we need to know about cells, right? Right? So technically they're separated by dry cell and wet cell. So dry cells like those batteries that you would normally see, like in back here, I think. Like fuel cell and thing, those are dry cells, and the ones that you see in cars, those are wet cells. Right? We call them secondary cells as well. The initially the dry cells, you couldn't charge them, but now you can kind of charge them, right? And of course, the batteries in cars, we could definitely charge them. Portable, right? Primary, yes, we could definitely move them around. Secondary, they're large, right? Voltage, real small values. Cars, much larger. Internal resistance high, cars lower, secondary lower. And these are the structures of them. All I would want you to do for homework, that's a draw one each. Draw a dry cell and draw a wet cell, right? Draw a primary and draw a secondary. Okay, right, just do my favor and take on that table. Then we talk about that, right? Leave a little space underneath. Leave a little space underneath for the dry cell. right? Leaving space to draw it, right? Leave a little space if you want to draw itself, table it, and the secondary cell. Yeah. Okay. Yeah, so, thanks. Give it up. Right? Leave it as space, right? All right. So the last thing that we need to learn about in electricity is the diode, right? All right, I see. Anyway, I'll give you the note, right? So head up direct and alternating currents, and then we'll take a look at the diode, right? So some of the things, some of the devices that we have, so watch this here. Some devices that we have, like a battery, they supply voltage constantly over time until it dies, right? But some of them, they give you a fluctuating value, like a value that starts at zero, goes up to a positive maximum, goes back to zero, negative, and so on. Okay, so you have an alternating supply and you have a direct supply. Okay, we are going to try. Which one you all think your phone will use? Alternating or direct? Think of your phone. Your phone's ever come on bright and come off and be off, then bright again. It will be like that or the constant supply. Imagine what TikTok and then you watch it and then it disappear. And it come back again. You want that? No. What you want? A constant supply, right? So your phones will be using DC, right? But one of the problems is that alternating is what's being transmitted. Like for example, the current on the wires are being transmitted from CSEC station to the generate to the transformer. Those are alternating because it's more efficient, right? But we need to go from alternating to direct. So I'm going to explain how to do that using a diagram. All right. So let's do my favor, head up direct and alternating and draw those two circuits. Right. Well, we'll do that next week, but I wouldn't rush on with that. Finish, finish, right? So alternating, quick little thing, alternating current is a specific type of electric current in which the direction is always reversed, right? So watch it here, right? If you look at this diagram here, what you will notice is at one point in time, positive, and next point in time is negative. Okay, so there's a constant change in polarity. You'll see now, there's a constant change, but in a direct, it's always the same. Okay, always positive, or in some cases always negative. What you all think this is? AC or DC? AC or DC? Who say AC? AC? No AC? DC? Okay, pick one. I have to pick one. Right? The answer is DC. Right? But in varying. All positive direction is the same all the time. So it's called varying DC. Right? Only like this, or you'll think this is. If you're looking like that, AC. All the way. Right? Once the direction goes this change it takes it AC. So this is a AC and this is a DC. That's okay? Make a small note and that's be right. Right, quick and that's it. Okay, so next day we will learn about the diodes and half wave and that's it. Can I get a little test on it? Okay, that's it.